pay attention to me. Please and please. So this is going to be just like yesterday or the day before when we did notes. I am going to go through all of the notes first, and then I'll go to the Delta Math assignment. So today's lesson is all about average rate of change, which again, I will say that every single every single spiral review that we have done this year through Delta Math has had an average rate of change question on it. Every single one. So it says, given the function defined in the table below, find the average rate of change in simplest form over the interval 1, 9. So this is just asking you, and I'm gonna pull up Desmos as well so you guys can see this. This is saying when x is 1, what is y? When x is 1, what is y? 38, okay. And when x is 9, what is y? Okay. So remember, this is just slope. Average rate of change is just slope. So I set this up like a table of values. These are your x's and these are your y's. So you're finding the change. You're finding the change in y. That little symbol is called a delta. It stands for change. Over the change in x. The word when we say the change, it's the same thing as the difference, right? You take the top number and subtract the bottom number. You just have to watch out because sometimes your numbers have negatives in there. So we're looking for the difference between the first y coordinate and the second y coordinate. So I know that 38 minus 14 is 24. Now I have to look for the difference between the first and the second. And this is a negative 24, right? Because I said it's 24 less. So what about the change in x? Did I add something or subtract something? I added. How much did I add? I added 8. Okay. So let's see. My change in y, negative 24, over my change in x, which is a positive 8, equals what? It's not 4. It equals negative 3. Yeah, it equals negative 3. So your average rate of change is negative 3. Okay, so for the next one, I'm given a function. My function, h of x, equals x squared minus 6x. Ooh, I need to look. That shouldn't be a minus. That should probably be, this should be a plus. Change that from an equal sign to a plus. Plus 4. Do you all see that where it says equals 4? Put a plus there. So we tend to make mistakes when we have to square negatives. We just make mistakes. I don't know why we do, but we just do. So if I go to y equals in my calculator and I put this in, x squared minus 6x plus 4. So I'm going to my calculator and I'm inputting this. I want everyone to pick up their calculator. God bless you. Pick up your calculators. Y equals. You guys don't, any of you have calculators? Nobody grabbed them? Okay, that's fine. So come up and grab calculators. Get up. Everybody, get up. You're sound asleep anyway. Get up and grab your calculator. Just grab a calculator. I don't care what number you have. I'll fix them later. Just grab a calculator. Dancing. No. Cover your mouth when you cough. That's what she's saying. Cover your mouth when you cough. Okay. Y equals, go to that. Y equals, type in x squared minus 6x plus 4. I need a table. How am I going to do that?
Second graph.
So when I go to second graph, I need to find out what my output is when x is -2. And I need to find out what my output is when x is +5. Ashton, when x is -2, what is y? -20. Lorenzo, when x is 5, put your hand down, Ashton. When x is 5, what is y? -1. Do you all concur? Did you get +20 or -20, Ashton? Okay, can you go back to your equation so I can look at it? You didn't put an x after your 6. You see that? And you did a negative, which should be minus 6x. Okay, +20 and -1. +20 and -1. So let's talk about that. Is y getting bigger or getting smaller? Getting smaller. So what do I take away from 20 to make it equal -1? Take away what? Take away 21. I take away 21. Here's how I want you guys to think about this. To go from 20 to 0, that's -20. And then to go from 0 to -1, that's another -1. I mean, you know how to get from any number to 0, you just add its opposite. Okay. What about on the change in y or change in x? What's my change in x? Say again. +7. So my change in y over my change in x. Let's see. I have a -21 and a +7. What is -21 divided by +7? It's -3. Oh my gosh, that's 2 in a row that have been negatives. And the same answer, -3. Okay, are we good with that? Okay, close your Chromebook. Thank you. All right, next one. So it says the function y equals f of x is graphed below. What is the average rate of change of the function f of x on the interval -9 is less than or equal to x is less than or equal to -4? This is the same thing as saying, hey, when x is -9, what is y? And then when x is -4, what is y? It's all it's asking us. It's no different than what we've been doing. We're just looking at a graph instead of a table. So when x is -9, it looks like y is what? -16. And when x is -4, it looks like y is -4. Well, you guys learned about slope by counting, right? That's how we initially taught you slope. So if I plot those 2 points that we just talked about and connect them with a line segment, can't I count my rise and my run right on the graph? So how much do I rise? Yep, I rise 6. So it's a +6 over, I always run to the right. I heard someone say it. 5. Yeah, good job, Carla. So my average rate of change is 6/5. Average rate of change is 6/5. Okay. Let's look at the next one. The next one is going to be a comparison. We're comparing. We have to figure out which interval has the smallest rate of change. Over which interval is there the smallest rate of change? Okay. So let's check the interval from 2 to 11. So when x is 2, my output is 624. And when x is 11, my output is 838. So what is the difference between the y's? Take 838 minus 624 and tell me what you get. 838 minus 624. 214. Yep. What about 11 minus 2? 9. Okay. So what is 214 divided by 9? 23.7. It doesn't terminate. It's like 0.7 repeating. Okay. Thank you. So this is when x equals 2 and x equals 11. That's my first interval. Okay. So what about the 11 to 20 interval? Let's see. When x is 11, my output is 838. And when x is 20, my output is 1,324. Okay. So take 1,324 minus 838. Yeah, I think it should be 480 something. What'd you get?
487.
Yeah, 486. 486. What about 20 minus 11? 9. I'm going to put that 486 down here. What is 486 divided by 9? 54. Okay. Now we have to go from when x is 20 and my output is 1324 to when x is 31 and I have an output of 1631. So 31 and 1631. So someone takes 1631 minus 1324. 307. Okay. So 307 divided by what's 31 minus 20? Okay. So what is 307 divided by 11? What is it? 20. Oh, 27.9. Okay. Last one. The interval starts at 31. When x is 31, I know that my output is 1,624. You guys, if you are coughing and you're not covering your mouth, I'm going to ask you to just walk out of the classroom because nobody needs to be sick. So if you're coughing, you better put your hand over your mouth or cough into your armpit or your elbow pit. I don't care, but you got to do it. Okay. 38, 1881. 38, 1881. So let's see. I'm going to take 1,881 and subtract 1,631. I should get 250, right? Okay, so this is 250 divided by what's 38 minus 31. So what is 250 divided by 7? So I'm just going to put it as 35.7. Okay, we need to know which one is the smallest. Which one is the smallest? Which one has the smallest rate of change? Yeah, the first one, the 2 to 11 range. When I go through the interval x of 2, x 11. Okay, x is 2, x is 11. Next, So for these last two examples that you guys do in Delta Math, it requires you to plot the points and draw a segment, just like I did on this one here. It requires that you plot the points and draw a segment. So we're going to have to do that, okay? So when we're plotting a line segment to figure out the average rate of change between x equals 7 and x equals 8. So when x equals 7, you guys see this right here? I plotted it in decimals. X equals 7 is right here. X equals 8 is right here. I'm going to put a special note here that says, watch how your y-axis is counted. Because it looks like, if I were just to count, it looks like I just go down 1 and to the right 1. But how is the x-axis actually being counted? What does this first grid line represent? Represents 5. So I'm not really going down 1. I'm going down 5 and over 1. So you got to look for that, okay? So it says use the line segment that you just drew to find the change in y. Well, your change in y is down 5. So that's -5. Your change in x is 1 unit to the right. And the x-axis is counted by ones. So your average rate of change is just, what is -5 over 1? Yeah, it's just -5. That's your average rate of change. So again, when you do that Delta Math activity, if you don't plot your points accurately and draw that line segment, it will not let you move on. Does that make sense? Like you can't just count it. And same for this one. Same for this one. So the function f of x is graphed below. Plot a line segment connecting the points on f where x equals -2 and where x equals 3. And then we're going to count the slope from the line segment. So when x is -2, I'm at, when x is -2, y is 0, right? And when x is +3, when x is +3, y is what? Let's see, 2, 4, 6, 8. This is -10, right? So your x-axis, your run is being counted by ones, but your rise is being counted by twos. So I'm going to go down 1, 2, 3, 4, 5, 6. Do you guys see that? Or 2, 4, 6, 8, 10. I go down 10. And then how many units do I run to the right? 1, 2, 3, 4, 5. So your average rate of change is -10 over 5. And that reduces to what? -2.